On my screen, the equation represents a quadratic function in two variables with a cross product term c times x times y. It is a quadratic function in standard form for two variables and represents a quadratic surface in three-dimensional space. The types of this surface depends on the coefficients a, b, and c, and the function can represent various shapes such as the ellipsoidal surface when both a and b have the same positive or negative side. The hyperbolic paraboloid surface when a is positive and b is negative, and vice versa. The C influences how the quadratic surface responds to changes in both x and y. If C is larger than 0, it tends to make the surface tilt or be stretched in one direction, where if C is smaller than 0, it tilts in the opposite direction. The magnitude of C determines the degree of tilt or stretching. In summary, C affects the orientation and shape of the surface by introducing a clause term that accounts for the interactions between x and y variables. The coefficients d, e, and f in the quadratic function contribute to the position of the quadratic surface in three-dimensional space. The term dx shifts the surface along the x-axis. The term ey shifts the surface along the y-axis. The constant term f represents a vertical shift along the z-axis. These three coefficients influence the position and orientation of the quadratic surface in relation to the coordinate axis. The simulated 3D surface plot in Power BI also allows us to rotate this quadratic surface and view its shape changes by different angles dynamically. Quadratic functions with two variables find application in many fields. For example, computer graphics, creating curved surface in 3D modeling and animation. In economics, analyzing supply and demand curves, and also other applications can be found in engineering, biology, and physics. In this video, I shall share an approach in Power BI R script visual on how to create a 3D quadratic surface simulator based on two independent variables quadratic function with 6 changeable coefficient parameters and 2 rotation angle levers. Open Power BI desktop and report view, name the page 1 as a 3D quadratic surface simulation. First, we need to create 8 parameter slicers. 2 slicers for surface view angles rotation and horizontal and vertical lever. Each angle for the 3D surface rotations and horizontal lever. V angle for the 3D surface rotations and vertical lever. Six slicers for A, B, C, D, E, F, which are represent the different coefficients in the function as explained before. A represents the influence of the variable x squared on the surface. It contributes to the curvature along the x-axis. B represents the influence of the variable y squared on the surface. It contributes to the curvature along the y-axis. C influences how the surface tears or deforms based on the joint value of x and y. D is the linear influence of x on the surface. E is the linear influence of y on the surface. F a constant term. It is a constant term that affects the overall position of the surface in the z direction. Move to the data view, we see 8 data tables created. Here you can do some parameters, value, type, and ranging adjustment if needed. Let's save the desktop file and do some formatting on the edge slicers. Now we can start to create R scripts for 3D quadratic surface. Step 1. Add R script visual into the report pager. Enable it. Step 2. Add all 8 parameters value field into the value area of the R script visual. Step 3. Create the scripts by launching the external R IDE while clicking the Launch External R IDE button on the top right menu of the R script editor. In this demo, I'm using RStudio as my external R IDE. If you do not know how to install RStudio and link it to the Power BI desktop file, please refer to my previous video, which is popped up in top right corner now. Step 4. Create the R script in RStudio source panel. Load the dataset of Power BI desktop file to the studio. To create a 3D surface plot, we need to install our Lattice package. Load the package and run the code line. Create 2 parameter variables for rotating view angles. Run the 2 lines. In the console panel, let's run view code to the edge angle. We see a transferred value 45 from Power BI desktop. Create 6 coefficient parameters variable. Run the 6 lines. Create data for a quadratic surface. This line creates a vector x containing 100 equally spaced value ranging from -5 to 5. The seq function is used for generating sequences. Similarly, this line creates a vector y with the same property, containing 100 values ranging from -5 to 5. This line of code generates a 2D matrix Z by evaluating a quadratic expression in terms of x and y for all pairs of elements from the vectors x and y. The outer function is used to create a matrix by applying a binary function to all pairs of elements from the vectors x and y. Then indicate our two variables quadratic function to be applied. This is a function that is applied to each pairs of element x and y from the vectors x and y. Along these three lines, let's view the variable z. We see 100 rows times 100 columns matrix generated. Use wireframe function to plot the quadratic surface. In wireframe function, define the formula to specify that the variable z is a function of the variables x and y. Creates a data frame with all combinations of x and y values. This expanded grid is used as a data source for the wireframe plot. Set the color of the wireframe to blue. Indicates that the color should be draped over the surface, meaning the color represents the surface rather than the wires. Customize the scales. In this case, it turns off arrows on the scales. Set the main title of the plot. Set the labels for the x, y, and z axes respectively. The screen is used to control the orientation of the 3D plot. H angles and V angles are the predefined variables representing horizontal and vertical angles respectively. This parameter controls the orientation of the plot. Run the last part code lines. We see a 3D quadratic surface plot appears in plot panel. Let's copy the whole created R scripts and paste them back to the Power BI desktop file. Run the script. Yes, we see a same type of a 3D quadratic surface plot appears in R script visual. Finally, let's add a text box in the surface visual to indicate the quadratic function. Let's change the different parameters by moving slicers in report pager. We see different types of 3D quadratic surface with different rotation views as we demonstrated in the beginning of this video. Let's save the Power BI file and publish it to the Power BI service. On the Power BI service, we see the simulation of the plot is working as in the Power BI desktop. That is all about in this video. In the video, I have shared detailed steps and R script codes on creating 3D quadratic surface plot in Power BI desktop. With changing the 8 parameters slicers in Power BI Visual, We are able to simulate the different types of the 3D quadratic surface with the view angles and the level of horizontal and vertical. The link of the R script codes for the video I have attached in the video descriptions in below. Hope this video brings some helps for you project development. Thanks for watching. If you like to watch more videos from my channel, please press subscribe button. See you in next video.